I'll show you on how to use LCR meter to measure resistor, capacitor and inductor. Okay, this is a resistor. So before we start making any measurement, we will familiarize with the LCR meter that we have. So this is a manual range. If you want to put the range in whole mode, means that you are the one that is setting the range of the value. Put it on hold, and then you can start putting the value that you want. So you before you do the measurement, you already knew that what is the value of the resistor. You just want to find what is the actual value. Else you put it in auto mode, the machine will automatically try to measure what is the actual the range of your resistor. So let's start do some measurement. So you put it on R. So this is a function, the device that you want to measure: inductor, capacitor and resistor. So for a resistor, the circuit mode is not that significant. The level, I'll talk about it later. And then the frequency is not significant. The trigger will tell you the internal trigger or external trigger from the back. So this is the whole for the range. So it depends on the value of resistor. If the value of the resistor is big, you put it on 1 volt. If the value of the resistor is small, you put it on 50 millivolt. The frequency I will explain later when we measure capacitor. Okay, so this is the resistor. We measure, we know that this is 968 ohms. See, if I put this thing in the hole, then I can play around the range. So you see, if this thing in tens, this is over, then we have to increase the value. So now this is in kilo ohms, 0.968 kilo ohms, and then it will lock to this. Okay, we can also do with auto. This is auto range. Okay, now let's start to make some measurement with a capacitor. Since there is no polarity on this capacitor, you can put to any of the terminals. Okay, so now what we need to do is to change the function into capacitor, and then we basically knew that what is the range of the capacitor. So if the value is small, so we put it on 1 volt. Since this is small, put it in 1 kilohertz. Internal trigger C. So now this is the circuit mode, either parallel mode or serial mode. If the value of capacitor is small, we put it in parallel mode. Means that the value of there is a resistor in parallel with the parallel resistor with the capacitor. So what we have is this dissipation factor, or the quality of the capacitor. The other one, if we have a large value of capacitor, something like this, we note the terminals. So the negative terminals go to the negative probe, positive terminals go to the positive probe. Okay, now what we need to do is to change the frequency from high frequency to low frequency. Okay, and then we put this thing in series. Means that there is a series of a resistor to the capacitor. So this D will indicate the ESR, or equivalent series resistance. So there is a resistor that is equivalent to the quality of the capacitor, which will give you the dissipation factor. So the value of this is 470 microfarad. Since this is a large capacitor, so 120 hertz, and this thing is series, so we can also put into auto mode. So this will tell you that this is a series resistor, so this indicate ESR. Same thing with I'll show you on how to measure an inductor. So this is a large inductor. We put it on 120 hertz. Internal trigger. This will give you a 10 Henry, but this is in series. There is a resistance in series of this inductor because we have a large inductor. So the value of this inductor is 9.5 Henry. So this is the dissipation factor. This will tell you the quality of the inductor. If you still remember, in the band pass filter, there is a quality that will give you some idea on how narrow band of this inductor will be. Okay, now let's change this to a different kind of inductor, a small inductor, small value inductor. Again, this has no terminals. Okay, so small inductor, we put it on 1 kilohertz inductor, resistor in series. So the value of this is 0.1 Henry or 104 millihenry. Okay, you can also put this thing in parallel, and then you'll see that the value is different and the dissipation factor is also different. This is to indicate a leakage resistance across the inductor at high frequency. But we normally know that there will be a series resistor to this inductor. So this will give you a better or closer reading to the actual thing. As the frequency goes higher, so this will be your value. For low frequency, this will be your value. Okay, this is about LCR meter. Next, I will show you on how to use curve tracer in the next video.